In this video, we are going to use what we've been talking about the past few days. We're using Pythagorean Theorem, but we're going to apply this to some real-world problems. I put real-world problems in air quotes. Not all of these are super realistic for us. They're just going to be some word problems. We have some word problems, which means we're going to use cubes. Remember that cubes is where we circle the important numbers. We're underlining the question. We're putting a box around the important stuff. Important stuff. There's a real box. Better box. Eliminate the extra stuff. Eliminate anything extra. And then we can set up and solve. Set up and solve. Especially with any kind of geometry topic, it's important that when you set up and solve, you're drawing a picture and labeling the picture. And you really need to ask yourself, this is part of the setup, do you want the missing side length or is there more work after? So a good example of that is looking at number 1. The question says, what is the length of the diagonal? So the question's asking me for the length of the diagonal that they've got labeled right there. So I want to know what C is. My important numbers are 6 inches, 6 inches, and C, measured in inches, because that gives me the dimensions of my right triangle. This is 6. I know that this length is the same as this length, which is 6. These are inches. And that diagonal is C. This makes a right triangle. Now, they've told me that I want the length of this, so once I use Pythagorean Theorem to find that missing side length, I'm done. So there's not more work after here in number 1. So we'll start out with a squared plus b squared equals c squared. Here's my right angle, so this and this are a and b. A is 6, so a squared is 6 squared. B is 6, so b squared is 6 squared. We don't know what c is, that's going to stay as c squared. 6 squared is 36. I have 36 plus 36 equals c squared. So 36 plus 36 is 72. And now we need 72 equals c squared. And that's not done. We've only solved for c squared, and our goal is c. To undo a square, we do the opposite of square to the other side. That's square root. So c is the square root of 72. The square root of 72. Second, if you're using an 83 or the black calculators, that's the yellow button. If you're using an 84, that's a blue button. Then hit x squared. You'll see the square root symbol pop up on your screen. I want the square root of 72. And then hit enter. The square root of 72 is 8.48. We're going to round to the nearest tenths. So c is almost 8.48. Rounding to the nearest tenths means I will make that 4 a 5. So this is going to be 8 and 5 tenths measured in inches. An example where there might be more work afterwards is looking at number 5. This says Caitlin drove 11 miles south and then turned east. She drove 60 more miles. If she had driven in a straight line from where she started to her destination, how much less would Caitlin have driven? So I'm going to just draw a little compass. Remember, north, east, south, and west. Okay. So Caitlin, if she starts here and drives 11 miles south, she's driving down 11 miles. Then she turns east. This is east, so she turns this way, and she drives to her destination 60 miles. The question, and I'll underline that, is how much less would she have driven, and that's if she had driven in a straight line from the starting to the destination. Here's the start, here's the destination. If she had driven this line, how much would that have saved her? How much less would she have driven? So it's not asking me for the length of this line. It's asking how much less is this than taking this path. How much less is this path than this path? So first I have to find that path, and then I have to find the difference between this and what she drove. To find that, we're going to use Pythagorean Theorem because that makes a right angle. So I've got a right angled triangle with a missing side length. I use Pythagorean Theorem to find that missing side length. Here's the right angle, so A and B are 11 and 60. (11 squared is 121. 60 squared is 3600. C squared, I don't know. 121 plus 3600, 3600, is 3721 equals C squared. And again, this is C. We have this solved for C squared. To undo the square, we square root the other side. So C is equal to the square root of 3721. You can type that in your calculators. You get 61. So this path is 61 miles. What she's already driven is this path that I just highlighted in pink. She's already driven 11 plus 60. 11 plus 60 is 71. If she had driven 61, how much would that have saved her? How much less? 71 minus 61 is 10. The difference there is 10 miles, so she would have saved driving 10 miles if she had taken the hypotenuse instead of the two legs. Who knew Pythagorean Theorem would save us gas money? So this is an example where you weren't just looking for the missing side length, there was more work afterwards. Looking at number 2, I want to know how long is that kite string. So here's the kite. This is a weird example. The string's going here. The string's really supposed to be going here, because that's where the little guy is flying the kite at. How long is this kite string? Okay. So my numbers, I'm going to circle them, are 30 and 25. Underline the question, how long is the kite string? My important information is this picture, and then everything else is eliminated because I'm just going to ignore it. So I'm looking for the length of the kite string, which is right here. I've got a right triangle with a missing side. I just used Pythagorean Theorem to find that side. And since this is what I'm looking for, there's no extra work afterwards. I'll use Pythagorean Theorem. A squared plus B squared equals C squared. A is one of the legs. I'll pick 25. It's 25 squared. B is 30, so B squared is 30 squared, equals C squared. 25 squared, that's one you should have memorized, 625, plus 30 squared is 900, equals C squared. You can add those together. You get 1,525 equals C squared. Use your calculator to find the square root. Once you take the square root of this side, that undoes the square on the C. So we've got the square root of 1,525. Now we get about 39.051, and that keeps going. This is irrational. Keep going. I'm going to round to the nearest tenths place. That's the 0. So look behind the 0, we see a 5. We'll add one more to the 0. This is 39.1 measured in meters. I'm looking at number 6. A cat is at the very top of a tree. To save the cat, Johnny leaned an 18-foot ladder 7 feet away from the tree trunk. How tall was the tree that the cat was in? So I'm going to circle my important numbers. This is 18, and this one's a little tricky. 7 is written in words instead of as numbers. I'll underline the question. U is for underline the question. How tall is the tree? Put a box around anything important. What's important about 18? It's an 18-foot ladder. What's important about 7? The ladder is 7 feet away from the tree trunk. And I'm going to eliminate everything else by just ignoring it. You can cross it out if that helps you. So I'm going to draw a picture. Here's a tree that my cat is in. And Johnny is going to lean his ladder against the tree. So there's a ladder. And he's done that 7 feet away from the tree trunk. Well, here's the tree trunk. The bottom of the ladder is 7 feet away from the tree trunk, so this is 7. The ladder is 18 feet, so this is 18, the diagonal length there. We want to know how tall is the tree. How tall is the tree is this length right here. So after I use Pythagorean theorem to find that length, I'm done. There's no extra work after using Pythagorean theorem in this problem. So using a squared plus b squared equals c squared, think about how this problem is different. A and b are the question mark in 7. I'll say that we'll leave a as the variable. That'll be the thing we don't know. That means b is 7, so b squared is 7 squared. And 18 is the length across from the hypotenuse, so c squared is 18 squared. So I've got a squared plus 7 squared is 49 equals 18 squared, 324. So now you need to subtract 49 from both sides of the equation. Minus 49. And you get a squared equals 275. Now you need to get rid of the square. To get rid of the square, you square root the other side. The square root of 275 is 16.583. It keeps going. It's irrational. We're going to round to the nearest tenths place. 16.58 becomes 16.6. And everything here was measured in feet. So this is going to be 16.6 feet. That tells me how tall the tree was. Looking at number 4, this is kind of another straightforward one. Just wants to know how tall is the ramp, how high is the ramp. So there's my question. Here's my important numbers. The important information is my picture, and then eliminating everything, just ignoring the extra fluff. To set up and solve this, I need to know how high is the ramp. That's this length right here. So I'm going to use Pythagorean theorem, find this length. I was looking for this length, so I'm done after I use Pythagorean theorem. Pythagorean theorem states that a squared plus b squared equals c squared. The square of the legs added together, the sum of the square of the legs, is equal to the square of the hypotenuse. I'll say that a is 10, so a squared is 10 squared. B is something that I don't know, so I'll keep that a variable. And C is across from the right angle. The hypotenuse is across the right angle, 15 squared. Now I've got 10 squared plus b squared equals 15 squared. 10 squared is 100 plus b squared equals 225. I want b squared all by itself, so we're going to take away 100 from both sides. 0 pair leaves me with b squared on the left. 225 minus 100 is 125 on the right. We're not done. We've solved for b squared, and we want to solve for b. We have to get rid of the square by taking the square root of the other side. The square root of 125, second x squared, 125, or 125, is 11.18. And again, we'll just round to the nearest tenth. So this will become 11.2. 11.18 is closer to 11.2. And this is measured in feet. That means the ramp was 11.2 feet high. That's a pretty tall ramp. Taller than most humans. All humans, I'd hope. Looking at number 6. Is that a pencil mark? Alright, number 6 says, Philip built a square picnic table for his mom. He wants the area of the tabletop to be 64 square feet. How long must each side of the table be? So, I should use cubes first. Circle my important numbers, that's 64. Underline the question, how long must the side of the table be? Circle any important, or box any important information. I think it's important that this is a square table. And the area of that square tabletop is 64 square feet. Eliminating all the extra stuff. To set up and solve, I'm going to draw a picture of this picnic table. 64 is the area of this square table, so that's the space it takes up on the inside. So that's 64 feet squared. We know the area, and we're looking for, what is this side length? I know that the area of the square is just the side length times the side length. We've got something times itself, that's something squared. Except I don't know what the side length is. I do know the area, 64 is the side squared. I would like to know just one of the sides, so I want to get rid of squared. To get rid of squared, we're taking the square root. The square root of 64 is 8. So each side must be 8 feet. That makes sense if I had 8 feet here and 8 feet here. The area would be 8 times 8, which is 64. Looking at number 7 now. This says Dalton went camping over Thanksgiving break, and his tent is shown below. How wide was the opening at the bottom of the tent? I'm going to circle my important numbers, which happen to be given to us in the picture. 10 feet, x feet, and 8 feet. Underline the question. How wide is the opening at the bottom of the tent? Put a box around the important information. I think the most important information is my picture here. Eliminate the extra stuff. Now I can set up and solve. What I want to point out is that x, I'll highlight in orange, x is this length right here. But the question, I'll highlight in green, was how wide is the tent at the bottom? How wide is the opening there? So the question's asking me for this. Let's draw this shape here off to the side. They're telling me this is 8, this is 10, here's a right angle, and this is x. Well, this triangle that I'm highlighting in yellow is exactly the same as this triangle, which means this portion is also x. So once I've used Pythagorean Theorem, I'll know x, but the question doesn't really want x. The question wants this x and this x, which is 2x's total. So our answer is going to be twice as much as what we find after we solve for the missing leg with Pythagorean theorem. We'll just turn the light back on. Okay. Now I've got a squared plus b squared equals c squared. I'm going to use Pythagorean theorem to find that missing side right here, or x. I can say that a is 8. That's one of my legs. That means x is the other leg, so b squared will be x squared. And c squared is 10 squared. Okay. 8 squared is 64. I don't know x squared, and 10 squared is 100. To solve, I'm going to take 64 away from both sides. 0 pair on the left leaves us with just x squared. 100 minus 64 is 36. A number squared is 36. 6 squared is 36. So x is 6. This is where I'm going to be tempted to stop because I found something. I found an answer. I said, hey, this is 6. Notice I want to know the whole green length. I need the other 6. 6 and 6 makes 12, or 2 times 6 is 12. And then this is feet. 12 feet down at the bottom. This was page 109 of our binders. This was Pythagorean theorem word problems, just applying Pythagorean theorem and potentially using several steps afterwards to find the real answer of whatever the word problem was asking. As always, if you have questions about the content in this video, message me on Schoology, shoot me an email, or drop a comment on this video, and I'll be glad to get back to you as soon as I can.